All right, can everybody hear me okay? Just let me know in the chat if you can hear me, I'm audible. All right, awesome. Everybody else ready? All right, cool. I will get started. Actually, let me do one thing first. Ready, one sec. There we go. I had some chill beats to teach Python to playing in the background, so I went ahead and turned those off. So yeah, let's get started. Okay, so this is the second lesson for Introduction to Python Programming. And I'm sorry, Victoria. Maybe next time I'll keep them on. So this is going to be an Introduction to Python Programming. This is the second lesson in a series that will continue for basically as long as I feel like it. But considering that we're mostly going to be indoors for a while, I'd say it has the chance of continuing for quite a while now. So I'm trying to, so for those of you that missed the first lesson, I'm trying to assemble a curriculum that is more or less about learning how to program in Python, not necessarily to become a software engineer, because for that I would be teaching it slightly differently. I'd be going into a bit more of the theory. In this case, this is a very high-level tutorial. And it's essentially just modeled so that you can get up and running, you can build a project. If you haven't already seen it, I do have a syllabus on the Classrooms page. And so for anybody that has not found the Classrooms page, this is the Classrooms page. And you can find all the information on any materials I present will be posted there. Any schedules, any notifications will all be posted on that website. So please check there. And then for those of you that don't know, my proposed lecture schedule is Sundays at 3 p.m., Tuesdays at 8 p.m., and Thursdays at 8 p.m. So sorry I couldn't join you guys on Tuesday. I had a bit of an incident on Tuesday, which rendered me rather incapable of teaching a lesson, but I'm ready to go today. So we'll just continue on with the second lesson. So let's talk about the first lesson. So on Sunday, what we covered were just some of the very basics of Python programming, how to do output and input, how to define functions, what conditional statements are on a pretty high level, how to do arithmetic and some of the arithmetic operators in Python, and then conditional operators. So the operators that we use to create the conditional statements. So if you remember, conditional statements are essentially just if some condition is met, do this, and then you might have an else statement that might just be like, if the number is even, print this number is even, else print this number is odd, for example. So I'm going to start off with a couple practice problems. So get ready. This is the first one I want you to try out. So let's say you have a function that looks like this, def. We use the word def to define a function, and then sum double, which is the name of the function. And then we have two parameters, a and b. So what I want you to do is, given two int values passed into this function, return their sum. But if the two values are the same, you should return double their sum. So take a few minutes and try that now. Also, if you had any difficulties installing PyCharm, I might just do a bit more of a deep dive on that later. I would actually recommend using this platform to do Python programming. I'm just going to paste it in the chat. So if you had any trouble getting your coding environment set up, I would actually just recommend using this instead. It's actually just pretty easy. It has the interpreter up and running in the service, and you can just run your programs. The interpreter will go through and let you do it. So go ahead and give that a shot. So try this problem out. So just to give you a quick hint, your program is going to look something like this. It's going to look like if A is equal to B, do something, else return, or I'm sorry, do something else. Would anybody like a little more time to work through this one? If so, that's totally fine. Okay, so the way this would look is you would say if A equals B, return A plus B times 2, else return A plus B. So then when we run this program, we'll see the results on the side. We have to print those results. My mistake. Okay. So then when we print it, yep. So we get what we expected. So when we had 3 and 4, the function returned 7. And when we have 4 and 4, since 4 and 4 do happen to be equal to each other, they happen to be the same number, we will return 4 plus 4 times 2, which is 16. So does anybody have any questions about this one? If not, we'll try the second one. Cool. Let's just move on to the second one. So for this function, given 2 int values, you're going to return true if one is positive and the other is negative, and you're going to return false otherwise. So if you have -3 and 3, the function will return true. If you have 3 and 3, the function is going to return false. So try this one out. So I'll go ahead and define another function here. Def positive, negative, A and B. And so we want to return true if A and B, if one is positive and the other is negative, and we're going to return false otherwise. So just for example, we might have, we have -3, 3. We're going to return true. If we have 9 and 7, that returns false. And then if we have 2 negatives, so if we have -1 and -5, that will also return false. So take a moment to try to figure this one out. And if anyone has any questions about this one, please let me know. Oh, also, just a pro tip if you're going to use Repellent. If you click the gear on the left side and you click theme dark, then you're going to have this dark theme and you're going to have essentially light text on dark background. I don't even really understand how people can code on white backgrounds at this point. But if that's your style, I'm not criticizing it. But I definitely prefer this. It's going to look a lot better. All right, so I'm going to just give you an idea of how to do this. So if you think about it, there are basically 4 possibilities here. You have A and B are both negative, A and B are both positive, and then you have A is negative, B is positive, and then you have A is positive, B is negative. So one good way of figuring this out is to just say, well, what's A times B, and is it greater than 0, or is it less than 0? And in this case, if you multiply two numbers together and they're positive, they're either both negative or both positive. And then if you multiply 2 numbers together and the product is negative, then you can actually assume that one of them is positive and one of them is negative. So something we can do is we can just say, if A times B is greater than 0, return true, else return false. I suppose I should have defined in the problem statement, assume that A and B are non-zero. Because 0 has an interesting property of being neither negative or positive. Does anybody have any questions about why this works? If A times B is greater than 0, return true, else return false. Go ahead and run it. Just do it. Oh, my mistake. It's actually if A times B is less than 0, that's what I meant. Right. So if you multiply two numbers together, one's negative, one's positive, the product will be negative. So that would actually be the real answer to that problem. And if you want to be really cool, you can do this. And I always recommend being as cool as possible. So you can actually just do this in one line, because A times B is less than 0 isn't in and of itself a Boolean expression, which means that it returns either true or false. So we actually don't even need the if-else. We can just return the Boolean expression as itself, and that would be totally fine. All right, so if nobody has any questions about that, I will move on. So I did assign some homework for last time. It wasn't a huge assignment, just filling in some functions. If I haven't graded yours yet, it means you probably submitted it today. I noticed a bunch came in today. That's totally fine. I'm not going to hold anybody to any strict schedules or anything like that. And at this moment, I am an unaccredited institution, so you don't have to worry about not getting your degree. So let's just go over some of the problems. Now, keep in mind that this is simply, I'm basically just going to be showing you one way to solve each of these problems. A lot of these problems can actually be solved in a far more succinct way, but I tried to only do it using Python, like Python features that I've already shown you before. So I tried to keep it just to like basic functions, conditionals, conditional expressions, and so forth. So for get minimum, if you want to get the minimum of these three numbers, you can say if number 1 is less than number 2 and number 1 is less than number 3, return number 1. Else if this condition is not true, we go and check this condition over here. Else if number 2 is less than number 1 and number 2 is less than number 3, return number 2. Else return number 3, because if neither number 1 or number 2 are the minimum, then only number 3 can actually be the minimum. For maximum, it's really just the same exact logic, except you're just basically flipping each of these conditional operators. So instead of less than, you're just testing if they're greater than. So if number 1 is greater than number 2 and number 3, you return number 1. Same thing for number 2, same thing for number 3. So to get the median, essentially what we're doing is we're going to be, we're looking for the number that's in the middle. So to do this, I basically just said, I used the functions we had already built, get maximum and get minimum. So I said max is get maximum of those three numbers, min is get minimum of those three numbers. So I said if number 1 is the min or the max, which essentially excludes it from being considered for the median, then if number 2 is the minimum or the maximum, then I'm going to return number 3. Because number 1 and number 2 were both the min or the max, so we're going to return number 3. Otherwise, we're just going to return number 2. And then if all those conditions aren't met, we can just return number 1. And then if we want to get the difference of max and min, all we really have to do is we just return the maximum of the three numbers minus the minimum of the 3 numbers. And that's all we have to do. So I tried to keep that assignment pretty short. So I'm excited to do some more interesting assignments in the future. That one wasn't particularly interesting, but I just wanted to give everybody an opportunity to try out some coding on their own. But we're gonna discuss a couple different concepts today, and then I'm gonna give you a chance to just kind of practice these on your own. So the first thing we're gonna look at today is the concept of the list. So lists are data structures, and a data structure is something that holds data. You're gonna see the concept of data structures everywhere in programming. It's an entire, like, data structures and algorithms is an entire field in computer science. But the most basic one that you're going to find in Python is the list. And essentially you can think of the list as a collection of items, either objects or values, and they're stored in a variable. So a list can be a roster of students in a class. So for example, if I took all the people in this watching the stream right now, I could put them in a list. It could be a grocery list. It could be the average rainfall in inches over the past 100 years per month. It can be anything you want. And you'll find that the list is pretty useful, and it gets used all the time. In fact, I was writing actual production code today, and I used Python lists. So go figure, they're actually pretty useful. So let's take a look at this code snippet. So in this code snippet, I have students in class. And students in class consists of 4 strings, which are just names of students. So I have Zara, Yorma, Vivian, and Xylophone. I made sure to comment that Xylophone just kind of had weird parents, so don't judge him too hard. But those are students in the class, and we hold them all in this variable. So the variable name is students in class, that's the name of the list. And the list itself contains 4 elements, which are these 4 strings, which are the names of the students. And we're going to use the name to manipulate the list, access its data. We're going to delete stuff, we're going to add stuff, and we're going to access it. So here's just a quick code snippet just to give you an idea of how to access the elements. So let's say I have students in class, so I define that variable up there. If I just say print students in class, Python will actually print out the whole list for me, which is pretty useful. Not every programming language will play that nicely if you just tell it to print out a data structure. But Python is pretty nice as far as usability goes, so it's just going to print out that whole list for you. And I don't think I mentioned this before, but you might notice that I defined the strings up here with double quotation marks, and then down here it's printing out each of the names with single apostrophes instead. In Python, they're essentially treated the same. So single apostrophes and quotation marks are actually more or less the same character to the Python interpreter, but it's useful to have 2 of them because sometimes you'll actually want to print out quotation marks. So if you want to print out quotation marks, you can actually encapsulate the double quotation marks inside of single quotes or vice versa. But don't worry about that. That's not relevant to what we're going to be doing today. If you want to access individual elements in the list, you would say students in class, and then inside these square brackets, you would pass a value. So like 0, 1, 2, or 3. This is weird when you first start out programming, but data structures typically start off indexed at 0. So you would say that Zara is the 0th element of students in class. You would say that Yorma is at index 1, Vivian at index 2, and Xylophone at index 3. So if you want to print them out, you would just say students in class, and then you put the index value that you want to print inside of these square brackets. And then you'll get Zara, Yorma, Vivian, Xylophone. Very, very cool. So like I said, lists start off indexed at 0. You're going to find that basically every data structure starts off indexed at 0. It's kind of weird when you first start doing it, or when you first start programming, but you'll get used to it really quickly, I promise. There's a special function called len that gives you the size of a data structure. So if I said, in the next slide you'll see. But if you say len students in class, Python will actually print out how many elements are in that list, which in this case is 4. And then there is also the append function, which places an element that you pass into append as an argument at the end of the list. So let's take a look and see how they work. Let's go ahead and just make that a little more readable. So if you say print len students in class, you're going to, oh no, I cut it off, sorry. Well, if you print len students in class, that's going to print out 4 currently, because we have 4, let's go back here. So we have 4 elements here, so the length of students in class is going to be 4. We have 1, 2, 3, 4 elements. You can't see that here because I did a bad copy and paste job. My mistake. If you print students in class, you're going to get what we saw before. Now let's say I say students in class dot append Chris, so I add myself to the class, and I print students in class again, you're going to see me at the end of the list now. So now the length of students in class is going to be 5. So before I move on with anything else, does anybody have any questions so far? I'm happy to stop and answer any questions that anybody might have. And also, Jacob, I have problems setting up interpreters in development environments all the time, so that never ends. It's always hard. I wouldn't feel bad about it. All right, awesome. Everybody seems like they're good. Like I said, though, feel free to just type a question in chat. I'm happy to answer. Because if you have a question, there's a very good chance that somebody else has that same question. I've kind of found that to be true in classrooms. So if you, so don't feel bad about asking a question. I actually find that when I'm meeting with other programmers, I spend more time asking questions than I do actually listening to a presentation. And programmers tend to ask a lot of questions. So don't see it as a weakness to ask questions. Actually see it as a strength. It's actually going to make you, if you're an engineer, scientist, I mean, really, if you're anything, asking questions is almost generally a good thing to do. I ask questions all the time, probably more than I used to. So let's say that we have, let's say that Zara drops the class, but we have Adam that wants to come in. So in that case, we would say students in class 0 gets Adam. So essentially this will say replace the 0th element in students in class with Adam. Now, if you actually want to drop something from a list, that's actually a good question. And it's actually a little bit weird. So let me go ahead and just do some quick coding here. Students in class, we got Zara, and I think we had Yorma, Vivian, Xylophone. So just print that real quick, just make sure that, let's do my sanity check. Yeah, so you can also access lists in a slightly different way. So if you want to drop something from a list, so let's say, for example, that we wanted to drop Zara, but keep Yorma, Vivian, and Xylophone, then you could actually just do this. And this is going to look kind of weird. Let me make sure my syntax is right there. Yep, okay. So a lot of things are actually lists in Python, like in the actual interpreter architecture, but don't really worry about what that means quite yet. In this case, I said, what if I just want to drop off the first value in the list? So there is a way to do this in Python that you won't actually find in other languages. It's actually one of my favorite parts of Python, is just getting a sublist or a substring, which is usually a huge pain in other languages. This basically says students in class, and then in the square brackets, 1:, is essentially just saying, take the list students in class, but then only take everything from the first index on from there. And then that's it. And then essentially what we're doing is we're reassigning that to students in class. So we are dropping the the 0th value from students in class. And then let's say you want to get the, let me think. Let me see. I'm just trying to think if there's anything else I'd like to show you in that. No, I think I'm going to show the rest. I mean, I'm going to show some fun things you can do with this later, especially when we start working with strings. But this is basically the idea now. If you want to just drop a value, you could use this indexing function that's built into Python, but I was planning on going over it a little bit later. It's a good question, though. But yeah, if you just want to replace, you can just say students in class, and then if we want to replace the 0th element with Adam, you could just do that. Yeah, so what if you want to drop a middle value? That's pretty much the exact question I knew would pop up, which is fantastic. I don't want to show quite yet, just because it's going to be somewhat confusing syntax for now, but I will show everybody later how to do it once we look at a couple more things. And if you drop a value and want to bring it back, you kind of can't. You're gonna, because in this case, when we drop the 0th value from students in class, Zara goes away. We reassign basically the list with Yorma, Vivian, and Xylophone to students in class. And then, so Zara at that point will be totally gone. So if you want to make sure that you can access that value again, you'll want to make sure that you do something like this. You'll say like drop student gets students in class 0, something like that. So that would be, so if you want to still keep track of the value, you would want to put it somewhere. You also might just have another list called drop students. And then you can say, down here, you can say drop students dot append, and then we'll just append students in class 0, something like that, to indicate that we just dropped Zara and we just wanted to add her to the drop students list. So that would be something you can do if you want to be able to access that value later. All right, so does that make sense to everybody? Lists and such. So I just want to be clear about something. For the first week, I'm actually kind of not going that deep into some of these concepts, and I'm doing that on purpose because I want you guys to be able to just kind of practice a little bit on your own and just do a couple like simple programs on your own. But I'm actually going to be doing deep dives into everything else we've talked about this week, starting next week, because I want to make sure that everybody does understand some of the deeper inner workings of Python, because even though it's a simple language on a high level, what you can do with it, you can actually do pretty wonderfully complex things with it. So anyway, I'm going to move on from lists for now. I might, if people have questions about them later, I'll answer them. And in the next lecture, I plan on doing a deeper dive into lists to make sure people understand them a little bit more, because there's a lot more to understand. So I want to talk about the concept of loops. Loops may be, besides conditionals, one of the most powerful ideas in programming. And a loop is essentially the idea that you do things over and over again. You have a block of code, and you want to just do the same thing over and over again while a particular condition is being met. Loops are everywhere in programming. They're extremely powerful and also extremely dangerous. Generally, if something breaks your... I find that 80% of the time when something breaks my code, it's probably in a loop somewhere. So you'll find that you'll probably break your own code with loops. And yeah, you'll see them everywhere. But this is the general idea. So you enter a loop, you check to see if a loop condition is met. If that loop condition is met, you do what's inside the loop body, and then you go back and check the loop condition. And essentially, you'll keep doing the loop, whatever code is in the loop body, while the loop condition is true. Otherwise, you are going to end. We're going to look at two types of loops in Python. We're going to look at while loops and for loops. So a while loop, I think, is actually a little more intuitively easier to understand when you're looking at them, but you'll find later that for loops are a lot easier to use. A while loop has a really simple structure. It basically just looks like while a condition. So while a condition is true, you execute a block statement. And that's it. So as long as a condition is being met, you execute that block statement. So we're going to look at a couple examples here. So this is one. Let's look at a loop that counts from 1 to 1,000. Let me just go ahead and make a new file here. Loops.py sounds good. So if we want to count from 1 to 1,000, what I'm going to do is I set up a counter first. I set up a counter with value 1. So we have a variable counter, and we are assigning a value of 1. And we're going to say while counter is less than or equal to 1,000, print counter, and then counter gets counter plus 1. So and that's incrementing counter. We're going to add 1 to counter. So let's go ahead and see what that does. And it runs my old code. Awesome. Oh, I only have a simple account on here, so I can only run one file. So I'm going to go ahead and let me take that stuff, put it somewhere, and I'll post it later. Because I just have to keep using the same file as long as I'm using Repellent. Okay. There we go. So if you run that yourself, you'll see that you basically get the numbers 1 through 1,000 printed on one line. Very cool. And if you just want to print 1 through 5, you can just change that number there. Pretty easy. So the way to think about this is you have this counter, which is equal to 1 at first, and while this condition is being met, the condition is that counter is less than or equal to 1,000, you print counter, and then you increment counter by 1, meaning just add 1 to it, each iteration of the while loop. And each round that the loop runs is called an iteration, so you'll hear me use the word iterate or iteration a lot, and it basically just means move through a looped process. Okay, so let's look at some other ones. So let's say we want to define a while loop that prints all even numbers from 2 to 1,000. It's going to be very similar to what we're doing here. It's just going to be slightly different. Print all even numbers from 2 to, what did I say, 2 to 1,000. Okay. Print all even numbers from 2 to 1,000. So for this one, I'm just going to start the counter at 2. And I'm going to say while counter is less than or equal to 1,000. So really just the same thing. Print counter. And then counter gets counter plus 2. So the only difference here is that I'm going to add 2 to the counter. And I'm going to go ahead and put these in functions so that I can just keep the code up, but then just run different ones by themselves. So count to 1,000 is here. And then I'm going to make this one def print all even numbers from 2 to 1,000. I'm being extremely this is okay. That's ridiculous. To 1,000, we'll just say that. I was getting really pedantic with my function names, which is something that people tell me sometimes that I tend to do. Let me just go ahead and put the comment up here. Awesome. So now if I just go ahead and run print all even numbers from to 1,000, we should see 2 to 1,000. Yep. So if you look at the output, we start at 2. Actually, doesn't look like we do. Hold on. Oh, sorry, I was looking at the old output. Yeah, no, it did what it's supposed to. So essentially, we started off at 2. Yep, right here. We started off at 2. And then we ended at 1,000. Cool. So go ahead and copy this and just comment it out so you can run it yourself if you want to. And then let's actually use lists. And let's go ahead and use a while loop to find the sum of all numbers in a list. So let's say we have this list of numbers here, numbers, 1, 5, 8, 9, 11, 20, 25. We're going to find the sum and return it. So let's define a function here. Find the sum of all numbers in a list passed as an argument. So we're going to say def get sum, and we're going to pass a list called list. We're going to I can talk. We're going to pass a parameter called list of numbers. And for this one, we're going to say this is going to look kind of weird at first. We're going to say total sum is 0, and we're going to say index is 0. So we're going to use index to count through the list. So if you remember, when we're working with lists, we say that everything is indexed at a particular position. So if you remember with students in class, we had Zara indexed at 0. We had Yorma indexed at 1. So essentially what we're going to do is we're going to create a loop that starts index at 0, and with each iteration of the loop, index is going to increment by 1 so that we can access the next element in the list. So we're going to say while index is less than the length of list of numbers. Remember that len list of numbers is going to give you the total number of elements in list of numbers. So for example, if we have 5 numbers, len of list of numbers is going to be 5. So we'll want to start with index 0, 1, 2, 3, 4. And the last element in the list is going to be indexed at 4. So we're going to say total sum gets total sum plus list of numbers and then index. And then we're going to say index gets index plus 1. So essentially what we're going to do is we're going to say add current value to total sum. Move that. Get those margins. Yep. And then we're going to add 1 to index. As we iterate through the list, we're going to keep adding that value to total sum. And then at the end, we can just say return total sum. So I'm adding some comments just for clarity's sake. So total sum is essentially just the running sum of all numbers in list of numbers. Index is the current index being accessed in list of numbers. So let me see if I know how to code. So I'm going to define a list of numbers here. And they can be any values we want. Let's go ahead and print that value out. So we're going to print out the result of calling getSum on this whole list of numbers here. Actually, just so you can see how it works, I'm just going to make that list small for now. So 3, 5, 6. So let's see how that looks. 14. And 3 plus 5 plus 6 is indeed 14. Very cool. I can get the sum of all the numbers in a list. Yeah, so when I say list of numbers index right here, essentially what that is, so list of numbers is the list being passed as an argument into the function. So if we want to access the list, we call list of numbers. And if we want to access a particular index in that list, we use the square brackets. And then we'll pass into those square brackets a value. In this case, that value is the variable index. So what's happening is index starts off at 0. So if we print out, let me just do this down here. So if we say print list of numbers 0, print list of numbers 1, print list of numbers 2, we just get 3, 5, and 6. So I'm using what look like real numbers there, but the truth is that index is actually just doing the same exact thing. Index starts off with 0, so since index is first 0, list of numbers 0, it's going to look at the 0th index of that list, and we're going to get 3. So Python's going to be like, oh, okay, that's 3. Neat. And then index increments by 1. So index goes up to 1. Just making my comments a little more readable. Yeah, it's better. So we're going to add 1 to index. So we go back to the condition in this while loop. Since 1 is still less than the length of list of numbers, which is 3, we continue iterating through this loop. So now we're going to add list of numbers 1 to total sum. So we're going to add 5. So now total sum is going to be 8. And then we're going to add 1 to index. So now index is 2. So now we have total sum is 8, index is 2. We'll go back to the condition. Index is 2 now. So since 2 is still less than the length of list of numbers, which is 3, we're going to add list of numbers 2, which in this case is 6, to total sum. So total sum is now 14. We're going to increment index by 1. So now index is 3. And then index, when we go back here, so we're going to have index is equal to 3. And then 3 is not less than the length of list of numbers. So we're actually done. So we exit the while loop and we go down here. And the last thing to do in the method is just to return total sum. So did that make sense? Like just kind of going through that? So I'm just going to give you 1 sec to make sure you understand that. So yeah, Python is a weird language. You don't actually have to, so it's called dynamically typed, and basically, let me make sure I'm using the right term there. Pretty sure that's what you call it, dynamically typed. Yeah, okay. So Python is a dynamically typed language versus a statically typed language like Java. Personally, I actually prefer statically typed languages, but in dynamically typed languages, you don't actually have to declare what type each of the variables are, because the Python interpreter during runtime will actually try to figure it out for you. There's both pros and cons to that. It makes it much quicker to get, yes, late binding is actually that's exactly what you're looking for. Yep. So like, for example, Java is when you run a Java program, you compile it down to Java bytecode first, and then the Java virtual machine will run the Java bytecode, which is a language that is just it's closer to machine language than Java actually is. Python actually has an interpreter that will essentially just go through each line and then run each line as it goes along. I think Python interpreters are written in C, but I might be wrong about that. I'm not entirely sure. I'm actually not like really a Python expert. I use it, but it's definitely not something where I like feel like I know all sorts of like trivia about it. But yes, you use something called late binding. Don't worry about that yet, though. Anyway, so let's move on. I'm going to move on to for loops. So for loops are another type of loop. You'll find that you'll use them a whole lot more than you would use while loops, just because they're simpler to write. Once you have an intuition for what you're looking at with a for loop, it's actually much easier to program with them. So one thing I want you to notice is that in each of the examples, we had a counter of some sort. And you'll find that most of the time when you're working with loops, you are going to be using a counter. So fortunately, there's something kind of cool that you can do called for loop. And a for loop allows you to actually write the counter into the syntax itself so that you don't have to declare another variable. So for example, I'm actually going to show you how to do all the same things we just did with the while loops. So I'll show you how to count from 1 to 1,000, print all even numbers from 2 to 1,000, and then find the sum of all numbers in the list using for loops. So here's an example of how to do this with a for loop. Let me go ahead and do it here. So I'm going to go ahead and just get rid of all this logic that we wrote. So if we want to, I'll save that for later. So let's say we want to count to 1,000. It's actually a lot quicker with for loops. We can just say for counter in range 1 to 1001. And then I'm just going to put 1 there, although we don't have to put that. That's optional. Print counter. And I'll explain why that's optional in a second. Oh, whoops. Count to 1,000. There we go. So you can see that this worked exactly the same. We started off with number 1, and then we saw that it prints all the way to 1,000. So I said that this parameter here in range is optional because the default value when you save range is actually just 1 anyway. So you don't really need to put the 1, but I put it there just to indicate to you that it exists. So if you want to, so that's called the step counter. So it's indicating with each iteration how much should the for loop be incrementing this variable counter. So by default, the for loop when you use range is always going to increment that counter by 1, but you can change that to be anything you want. I'll actually answer the late binding question later because I find it interesting, but it's a little past where we are right now. So let's say that we want all even numbers from 2 to 1,000. So this one is similarly pretty easy. You just say for counter and range, we start at 2. And at 1,001. So you'll notice that I'm putting 1,001 here instead of 1,000. That's because for some reason this is essentially, how can I explain it? Basically, this is just going to be like one passed the final value in whatever you're iterating over. The range function itself is actually a built-in Python function that generates a set, and there's a specific algorithm that it uses to generate the set. I'll go into more detail about that later, but just for now, realize that even though I'm trying to count to 1,000, I'm putting my end as 1,001, and there's a reason for that. It's just because that's the way Python is written. So if I want to print all the even numbers up to 1,000, first I have to uncomment the method that actually, or the line that actually calls that function. And then we actually get the results that we want. So essentially here what we're saying is counter starts off at 2, and while counter is less than 1,000, is less than 1,001, you print counter, and then you increment counter by 2. So for example, if we wanted to count by tens, just change the step to 10, and that's it. So that's why I said that you'll probably end up using for loops a lot more than you would use while loops, just because for loops take what you can do with while loops, but then just kind of like contract it into much more readable code, in my opinion. So it's pretty rare that I end up writing a while loop. I will almost always use for loops with everything I do. So let's say we want to get the sum now. So we're going to do the same thing, finding the sum of all numbers in a list. For loops especially help with this. And I'm going to show you why in 1 second, because you're going to, we don't actually have to use the range function here, although we could if we wanted to. So we could say, total sum is 0. And then we could say for index in range 0 to the length of list of numbers, total sum gets total sum plus list of numbers index. And then you just return total sum. So just quick sanity check. I'm actually slightly less confident in my Python than I am in my Java at this point. So please bear with me. I sometimes have to prove to myself that I know how to do it. Neat. Okay. So yeah, if you wanted to do it the way we did it with while loops, you would you could just say for index in range, while index is less than the length of list of numbers. You just add list of numbers index to the total sum. So it's the exact same thing we did with the while loop. There's literally no difference in the way that Python will interpret this. It's literally just written differently at a high level. You might find the while loop syntax a little easier to read. I personally find the for loop syntax easier to read. But I want to show you an alternative way to do it. Get some version 2. Because there's something else you can do with for loops that you can't really do with while loops, and I find this pretty cool. You can say for number in list of numbers, total sum gets total sum plus number, return total sum. Now I think that's pretty cool, because essentially what that's doing is it's saying it actually uses number and directly iterates over list of numbers, pulling those values out. So you don't actually have to mess around with index and saying list of numbers index. You can just say for number in list of numbers, and Python knows what you're talking about, and it's going to say, okay, well, I'm going to look at everything I see in list of numbers, and whenever I see something, that's number right now. So it's going to look at 3 and say, that's number. And then it's going to look at 5 and say, that's number. And then it's going to look at 8 or 6 and say, that's number. So just to prove to you that this works, there you go. So both of those work. I think it's pretty cool. So I have a couple questions here, good ones. So in most coding language, the to is not inclusive of. I feel, yeah, like in JavaScript, you might have seen that as well. Yeah, so like you'll find that different languages handle inclusivity slightly differently. So you'll see that some languages are inclusive, non-inclusive. So it kind of just depends on the language. In Python, for loops, the range function at least is non-inclusive. And honestly, that actually kind of makes it a bit easier if you look at how we wrote this out here, like length list of numbers. I think that's actually a little bit like cleaner. You'll just kind of have to get used to thinking about it in that way. If you're having trouble intuiting what is happening logically, I would actually recommend just using while loops because you have a lot more control over the condition. And you can just say like while index is less than 3, and like that's it. You can just kind of define it exactly as you want to. But once you get more comfortable with the logic, the underlying logic, then I would recommend just using something like for loops. So what if I put something in the getSum method that was not a list of numbers? How would Python know then not to apply that method? Actually, it doesn't, and that's a really, really good question. So let's go ahead and do that. So I'm going to go ahead and put in a list of strings. So let's see what happens when we pass... Actually, the second one might still... I want to see what happens, but I'm pretty sure we're just going to get an exception, but we'll see. So if I say get some list of numbers, you'll notice that these are not numbers. These are all strings. That's bad. Let's see what happens. Yep. So we actually get something called a exception. In Python, like these are actually errors. Exception has a specific meaning in Python that's a little bit different. So these are actually errors. So what this says is unsupported operand type for plus int and string. And the reason it didn't like that is because we defined total sum here as 0, and then we're trying to add a string to an integer, which it does not like. So let me make sure it does the same thing for getSum version 2. Yep, and it does the same thing. So basically, yeah, like if you pass some... So this is actually the issue with a dynamically typed language, and it's the kind of thing I don't like because you might not catch some of these things, and you cannot expect the users of your programs to be educated and intelligent enough to know how to use your software and understand kind of like how it works. And B, you can definitely not expect your customers or like the people that use your software to not be malicious because people will take any opportunity to try to mess with your code. And actually, programmers kind of take a sort of... programmers tend to take a sort of pleasure in trying to break programs, not like other people's stuff, but like they generally enjoy trying to find mistakes and errors and ways to quote-unquote break code. And once you learn what to look for, you'll notice everywhere, like all over the internet, there's all sorts of ways to break stuff, which is kind of what white hat hacking is, meaning like you look for ways to break things and then tell the owners of that software that something is broken and that you can fix it. And black hat hackers would be doing things like actually trying to do that malicious stuff to steal things, which is becoming more and more prominent in today's world. If you pay attention to news at all, which I would not recommend at this moment. So anyway, but yeah, that's actually a really good question. So yeah, if you pass in a list of something that is not numbers, Python will throw an error. List of numbers isn't actually a keyword. List of numbers is just a variable name that I keep using. It's arbitrary, though. So, yep, good question. So, I want you to try this out yourself. This is a practice problem, and basically you are going to return the largest number in a list. So I will put in a code snippet down here. And since I keep using list of numbers as a argument name, I'll just keep it the same here. So try to fill in this function. Now, just to be clear, you can totally just do this. And this is like, but that's not the point. So you can actually do this. Just return max list of numbers. And you will get the right answer. But the point is, I don't want you to use this. I actually want you to actually use loops, iterate through the list, and keep track of the variable and try to figure out what the maximum number is. So yeah, take a few minutes and try that. I'm going to go get a drink of water. And yes, Python absolutely keeps track of your indentations. So the area of indentation is called white space. So you'll notice that this has 2 spaces of white space, and then this is 4 spaces of white space. So I use tabs when I code. Some people like to use spaces when they code. And it may not actually seem like a big deal, but you'd actually be shocked at how many programmers have like pretty rabid opinions about this. And like I've seen straight up arguments between programmers about whether we should be using tabs or spaces as a coding paradigm. I'm on the tab side, by the way, so if you want to join my army, tabs army, hashtag, then please let me know, and we invade on Sunday. Don't tell anyone, though. It's our secret. So anyway, yeah, take a few minutes and try to solve this problem. Largest number in list. And I'm going to put on some cool beats to code to. Glad you enjoy. I will be back soon. just a fun aside about lo-fi hip-hop beats. Let me just turn it down a little bit. Me and my team are working remotely now because of world events, and so none of us are physically in the office. We're all working remotely. It's been a rather uncomfortable experiment for all of us. It turns out it's really hard to do that, and I kind of miss being physically around teammates to work. And so we do things like we trade music back and forth, and we say like, hey, what's everybody listening to while we're working on something? And so one time in a chat, we all just posted exactly what we were listening to, like any music or whatever, and 4 different people actually posted this same exact just lo-fi hip-hop beats YouTube video. It was kind of funny that all of us were all that predictable. Turns out it's really good for coding. Anyway, let's take a look. So let's get the largest number in the list. So we're gonna say the there are a couple ways to do this. So we're gonna set the current max of the list to be list of number 0. So we're also going to assume so one second, gets the largest number in the list. Assume that there are at least one number. There is, I promise, I know English, at least one number in the list of numbers. So what you can do is you can always just set the current max to be list of number 0. And then you can say for number in list of numbers, if number is greater than current max, set the current max to number. And then at the end, we'll just return current max. So there's a lot going on there that I will try to explain. So basically what's happening is we just assume that the current max in the list, I have to mute the beat, sorry. The current value in the list, the current maximum value in the list we'll assume is the first thing in the list. And we'll say right now we're just going to consider that the current maximum in the list. And then we just loop through each of the numbers in list of numbers, and then we'll say if that number is greater than whatever the current max is, we just set the current max to that number. And then we're going to return current max. So just to prove to you that this does indeed work, honestly, the Repellent, I don't usually use this, but the Repellent editor is actually kind of good. It has a lot of really good autofill in it. I usually don't expect that from online stuff, but lo and behold, stuff is, a lot of free online services are pretty good. So we would expect this to return 6. Yep. So the maximum value in here is 6. Now, a lot of times when people do this problem, they will do this. They'll set current max equal to 0. So can anybody type in chat a reason why you don't want to do this? There are edge cases where that would actually cause your code to produce incorrect return data. So, can you give me an example of when setting current max to 0 would actually end up breaking your code? Or basically, give me a list of numbers where this would not work. Very good. Yeah, exactly. If the list is all negative, then it won't work. So if I do, -3, -5, -6, the max value in the list is actually -3. But if we run it, we would end up getting 0. So the only reason I brought that up is because that's something I actually saw a lot when I was teaching programming. This is a really common mistake to make. So a lot of times the easiest way to mitigate that potential error is to just say list of numbers 0. So you just assume that the current max is equal to the 0th value in that list. So, yep, you got it. Yeah, so any questions about that? Okay, so this is a fun one. This is actually a so you can always do anything you can do in a for loop with a while loop. So yes, and yeah, why don't we go ahead and just do it with a while loop too? I think it's actually just a good thing to do. Call it while. So we could say index is 0, and then while index is less than the length of the list of numbers. Whoops. So we just replace number, though. We would say if list of numbers index is greater than current max, list of numbers index, or current max gets list of numbers index. So that's just doing the same exact thing. So anytime you can do something with a for loop, you can also do it with a while loop. They are one-to-one functions in a sense. So I'm just going to have you finish off tonight with a practice problem that is quite legendary at this point. It's called FizzBuzz. And the way it works is you're going to write a program that prints each number from 1 to 100 on a new line, but there are some caveats. So for each multiple of 3, you're going to print fizz instead of the number. For each multiple of 5, you'll print buzz. But if a number is a multiple of both 3 and 5, you print FizzBuzz instead of the number. Why do we do this? I have no idea, but we do it. And apparently this was a very common interview question until it became kind of well known in the programming community. So now I really doubt you'll ever see this in an interview. But, who knows, you might. But this is essentially what the problem is. So you're going to write a program that, let me just do this real quick. Let me clear that out. Save that. And then, so you're going to write FizzBuzz. If the number is a multiple of 3, print fizz. If the number is a multiple of 5, print buzz. If the number is a multiple of 3 and 5, print fizz buzz. Your code here. Oh my gosh. It's trying to autocorrect and it's not doing it. All right. Yep. So try to fill that in. So essentially, we just want to solve this problem. And for any sort of homework this weekend, honestly, I haven't assigned any. I'm getting kind of slammed at work because I am working like full-time remotely. So I don't think I am going to have the wherewithal to really grade any sort of projects this weekend. So But I am going to take time over the weekend to plan out lessons for the next couple weeks and plan out your first project and assignments. In the meantime, though, I would recommend just kind of going over the first couple lessons. If you want any additional resources, I can provide them for you. And specifically, I'm going to ask that everybody tries out this website, and I'll go through 1 or 2 problems with you just to show you how it works. This is actually one of my favorite sites for learning programming. It's called CodingBot, and basically what it is you get to you kind of just solve a bunch of coding puzzles. Now, if you're trying to and just so you're aware that like this is not just a filler activity, it's actually quite useful. There is a website called LeetCode that I use all the time, and programmers tend to use it for interview practice because a lot of interview practice questions tend to be like the type of things you'd see in LeetCode. Just go ahead and type the old password here. Oh, never mind. Okay. I use a different account for that. But basically, it's a website. I might show it to you guys later, but it's a website where you solve different coding puzzles, and they tend to be the kind of things that you'll see in actual interviews, so it's pretty cool. And CodingBat is a website where you can just solve little puzzles, and it turns out, though, that it's really useful for just like getting syntax down and just making sure that you understand kind of like the underlying concepts. I would highly recommend just making an account because it will keep track of all of your progress. But I'll show you guys that later. So in the interest of time, and because I am really excited to go eat dinner because I have been working all day, and I am quite tired, I'm going to show you how to solve FizzBuzz. Yeah. So for number in range 1 to 101, so we're going to say if number mod 15 is equal to 0, print FizzBuzz. Else if number mod 3 is equal to 0, print fizz. Let me make sure I'm not typing just old Python up there. Else if number is a multiple of 5, print buzz. Else print number. Now, this is probably one of the less interesting ways to do this problem. There are actually kind of some pretty hilarious ways that people will try to solve this problem. So another way you can do it is so let's say we have a value current string here. We can say if number is a multiple of 3, current string, you add fizz to it. If it's a multiple of 5, you'll just add the buzz to the end of it. And actually, we want to reset that value at the beginning. So you want to do it like this. If current string, if the length of current string is greater than 0, print current string, else print number. Yeah, that'll do it. Okay, so clearly I don't even know how to do this problem. I think I'm just getting tired. Sorry. But here, let me show you. Let me show you one of my favorite. I'm kind of just doing this on the fly, so I'm just. I want to show you my favorite FizzBuzz that I've seen, because it's almost kind of like a just like a contest between people to see who can come up with the most concise and ridiculous FizzBuzz. And I know I saw one. That's just what I wanted to end with, because I think it's rather funny. Yeah, so this is a solution for FizzBuzz. I wouldn't actually write this code, but that actually works. Perhaps you don't find it quite as amusing as I do, which is understandable, but I find like silly, concise code that is also unreadable to be rather amusing. Anyway. Yeah, so I'm getting pretty tired, but let me show you CodingBat real quick, because that is something that I'd like people to work on over the weekend. In addition, if you have questions about anything else that we've done so far, please let me know. You can just send me a message. You just prefer email, so just please email me, and you can just ask me whatever you want, and I will give you an answer to that. And if you want to have other reading material over the weekend, that's fine. Like I said, I want to take a few days just to assemble some more lessons. I've actually been a lot busier than I expected. But I will show you an example of CodingBat and why it's cool. So we'll do the first problem together. So the parameter weekday is true if it's a weekday, and the parameter vacation is true if we are on vacation. We sleep in if it is not a weekday, or we're on vacation. Return true if we sleep in. So basically this is saying we have a Boolean weekday, and I'm also looking at Java. Let me look at Python. So we have this parameter weekday, and we have this parameter vacation. So essentially what this is saying is if we're on vacation, we're going to sleep in. And if it's not a weekday, we're also going to sleep in. So we're going to say if not weekday or vacation, return true, else return false. So, yep, yeah, they're all really simple, and they're all stuff that you would have seen already. And so that's actually why I recommend going through as much of this as possible. I'm not going to say necessarily get up to something, this is your assignment. I mean, just go through however much you want to go through. I'd recommend at least doing like the warm-ups and try to do the list ones as well. I promise that if you do these, you actually will get much better at coding, and you'll just like start to understand a lot of these like initial concepts a lot easier. Also, if you need an added challenge, each of these problems can be done in, at least in warm-up, can be done in one line. So see if you can try to solve these problems in one line as well. But yeah, I will leave it there. I'm going to go eat some ramen, and I'm really excited. So Everybody have a good night. I hope you got something out of this, and I will see everybody on Sunday.